Good morning, Year 10s. Now, this reaction has nothing to do with the lesson that you have today. However, I just heard the screencast that I've provided for you, and my voice is so boring that I thought I had to spice up the video somehow. So, the reaction that you're seeing, just briefly, is the oxidation of mercury thiocyanate, and it's commonly called the Pharaoh snake reaction. You guys can check it up on YouTube if you want to. Unfortunately, we could never do this at our school because it requires a fume hood, and mercury, of course, is very, very toxic. So basically, not legal to do in a school in Australia. Still very interesting though, and you can always dream, you know. Anyway, I'll leave you now with my boring screencast about balancing equations, which is extremely important for your exam. Good luck, everyone. Hi, students. We will be starting balancing equations today. This video will show you how to use a step-by-step approach to balancing equations. You can re-watch this video as you need to, as long as you've brought your headphones with you to class. So balancing equations relates to the law of conservation of mass. This law says that matter is not created or destroyed in chemical reactions. The elements are simply rearranged into new substances. In the reaction shown above, we see that hydrogen gas and oxygen gas are changed into water. Importantly, there is no change in the mass of the substances between the reactants and the products, and there is no change in the number of atoms of an element. So on the products, we have 2 hydrogen gas molecules, which means 4 atoms of hydrogen, and in the products, we have 4 atoms of hydrogen again. Similarly, we have 2 atoms of oxygen in the reactants and 2 atoms of oxygen in the products. Balancing equations can seem confusing, but after a bit of practice, it's pretty simple. The equation on the screen is balanced. You can see 2 different sorts of numbers here. You can see coefficients. These are the large numbers in front of the different molecules of reactants and products. These will tell you how many of that molecule are involved in the reaction. So for example, we have 2 molecules of hydrochloric acid reacting with a single molecule of calcium carbonate here. This produces 1 molecule of water and 1 molecule of carbon dioxide, as well as 1 molecule of calcium chloride. You can also see subscripts which tell you how many atoms of an element are in a molecule. So for example, in calcium carbonate, we have 3 atoms of oxygen in a single molecule of calcium carbonate. In water, we have 2 atoms of hydrogen in the water molecule. When we balance equations, we only ever change the coefficients. So these numbers here are changed to balance the equation. We never change the subscripts. This is because if we change the subscripts, we will change the type of reactant or products. So if we had a 2 here on water, that would change the water to hydrogen peroxide. So here is the step-by-step method for balancing equations. When you balance equations, you should use this step-by-step approach, which I will demonstrate in the next slides. So the first part is to write out your equation. So you will sometimes be given a word equation and you have to write out the chemical equation for this. You then write a list of the number of atoms of reactants and products. So you will have a list under your reactants and a list under your products. You then add coefficients to the front of the compounds and molecules in the reaction to balance the equation. Last of all, as you add each coefficient, you write changes to the list of reactants and products until the numbers of atoms of each element are balanced on either side. So let's have a go. So when we have hydrogen gas and oxygen gas reacted together, we produce water. We can write this equation chemically using symbols like this. So this is step 1. You then need to write a list of the number of atoms of reactants and products, and this step is shown here. So we count out the number of atoms of hydrogen and oxygen on the reactant side, and we see that there are 2 atoms of hydrogen and 2 atoms of oxygen. On the product side, we have 2 atoms of hydrogen and a single atom of oxygen. Because this is not balanced, there is more oxygen on the reactant side than the product side, we can add a coefficient in front of the water molecule to increase the number of oxygen. Once we add the coefficient, we then have to change the number of atoms in our lists. So we've increased the number of hydrogens to 4 because 2 times 2 is 4, and we've increased the number of oxygen to 2 because there are 2 molecules of water, which means there is 2 oxygen atoms. You can see now that the equation is still not balanced because we have an excess of hydrogen on the product side. So we need to increase the hydrogen on the reactant side. We do this by adding a coefficient to the front of the hydrogen gas molecule. This is shown here. We then make changes to our lists, and we can see that this equation is now balanced. Let's do another example. Magnesium plus hydrochloric acid produces hydrogen gas and magnesium chloride. We can write this as a chemical equation like this below. The next step is to write a list of the atoms on the reactant side and the product side. This is done here. So on the reactant side, we have 1 magnesium, 1 hydrogen, and 1 chlorine atom. On the product side, we have 1 magnesium, we have 2 chlorine atoms, and we have 2 hydrogen atoms. So this equation is not balanced. We need to add a coefficient to the reactant side of the equation to increase the number of hydrogen and chlorine. So I'm going to add a coefficient in front of hydrochloric acid. We now have the same number of atoms on the reactant side as the product side. So we're going to do one more example. This one's more complex. This shows ammonia and copper 2 oxide reacting to form copper metal, water, and nitrogen gas. The first step is to write out your chemical equation. And the next step is to write out a list of the reactants and products. So we have to count the types of atoms and the numbers of atoms on either side of the equation. We can see that we have nitrogen atoms, we have hydrogen atoms, we have copper atoms, and oxygen atoms here. On the reactant side, we have 1 nitrogen atom, 3 hydrogen atoms, 1 copper atom, and 1 oxygen atom. On the product side, we have 2 nitrogen atoms. We have 2 hydrogen atoms. we have one copper atom and we have one oxygen atom. So this is not balanced and we need to balance the equation. The first thing I'm going to balance is to balance the nitrogen. I'm going to do this by adding a coefficient of 2 in front of the ammonia molecule on the reactant side of the equation. Once I've done that, I need to change the numbers in my lists on the reactant side. So you can see that I now have 2 nitrogen atoms, but I also have 6 hydrogen atoms. So now this is unbalanced because the number of hydrogens on the reactant side is larger than the product side. So I need to increase the number of hydrogens on my product side. The way that I'm going to do this is by adding a coefficient in front of the water molecule. Once I've done this, my nitrogen, my hydrogen, and my copper are balanced, but my oxygen is in excess on the product side. So I need to increase the copper on the reactant side. I'm going to do this by adding a coefficient in front of the copper oxide. I've added a coefficient of 3. This increases the number of oxygens to 3, which is the same as the product side, but it's also increased the number of copper to 3. So the last step would be to add a coefficient in front of the copper on the product side to increase the number of copper atoms there. Once this is done, you can see that the reaction is actually balanced because the number of atoms of each element is the same on the reactants and product side. So what you can see once you've seen a couple of examples of balancing equations is that it is a step-by-step methodical process, and if you can carry out this process methodically, then you'll get really good at balancing equations and it's no problem. But you have to start slow. So take your time, and I'd like you to work on balancing the equations from your booklet on page 51 to 52. Complete as many of these as you can, and if you complete 10 of them today, then you'll get a blue stamp from me on Wednesday. Enjoy!